In this video, we're going to look at section 8.6 on power series, example 5, part A. So here in example 5, we're asked to find the power series centered at x equals 0 for each of the following functions and find the interval of convergence. So if we look at the function that we're given in part A, it has a form similar to 1 over 1 minus x, or minus input. And why is that relevant? Well, we can look back at those power series that we have for some common functions and see that we have the general formula or layout for a power series of 1 over 1 minus x. So we can go ahead and use this power series for our work in example 5. So here I've just went ahead and copied that power series down so we can refer to it for this problem. And so one other thing that I should have copied is that interval of convergence. So this works for when x is between -1 and 1. All right, so now everywhere that we have x in this formula, I'm going to plug in our value to x. So this means our f of x is equal to 1 plus 2x plus 2x squared plus 2x cubed plus 2x to the 4th, etc. So let's go ahead and multiply out some of those terms. So I get 1 plus 2x plus 4x squared plus 2 cubed, x cubed, plus 2 to the 4, x to the 4th. So we can see that the series, I can see a pattern emerge quite quickly, and I'll erase that 4 and write in the 2 squared. So this looks like the series from n equals 0 to infinity of 2 to the 0, x to the 0 rather, 2 to the n, x to the n. For any term, we just have 2 and x raised to the nth power. Okay, cool. But what about convergence? So we saw in that formula that x, the input down here, has to be between -1 and 1. So for us, this means that this series has an interval of convergence when 2x goes between 1 and -1. Now, that's cool, but it's also a little sloppy, leaving it as 2x. So we need to solve for x here. So to do that, let's divide everything by 2. So that implies that -1/2 is less than x is less than 1/2. So in conclusion, we can say the series 1 over 1 minus 2x is equal to, or that my function has the power series, the sum n equals 0 to infinity of 2 to the n, x to the n, with an interval of convergence given by -1/2 x to 1/2. And notice that you might think, oh, well, maybe we should check convergence, or maybe we need to consider endpoints. Well, because we are starting with the interval of convergence given here, we know that those endpoints are not included. It would have told us if it was included. So these formulas here for the power series tell us that interval of convergence, or where it's valid for. And we can see that's even straight up. If x equals -1 or 1, we just get a sum of -1s or 1s. And we see that same behavior happens in our example. If this x was a 1/2, then all these terms would cancel out to be 1. So we'd be adding up 1 an infinite amount of times. So there we are.